The power supply survived the soak test. All the rails seem to be behaving themselves. I've cycled it on and off maybe 50 times. It's been running now for a total of probably over 20 hours with most of the rails loaded up to about 75 to 80% of their maximum capacity. It's not getting too hot. I've had some fans blowing across it. Nothing too outrageous, just enough to keep the airflow through it, some reasonable approximation to what it would have in the machine, probably a bit less actually. And I've been watching it every now and again with the thermal camera, looking for any hot spots, anything getting excessively hot, and it's fine. The two diodes that were showing signs of overheating previously weren't even getting warm, so we might well have an issue somewhere else in the system, possibly in the monitor, and we'll have to check that once we get the monitor reattached, or as we start adding the other boards. We'll keep an eye on those and monitor the rails as we start adding more parts. So the next step is to prepare the chassis to accept the power supply, and that means refitting some of the metalwork and the board racks. So I'll get this out of the way, we'll get the chassis onto the bench and start refitting some of the parts. So the next thing I'm going to fit is the power supply box, and as you can see, I've given this a good clean. It was a bit bent at the top, so I've straightened this out. The rest of it seems to be in very good condition. I've checked the wiring, no poor joints or anything like that, and it's cleaned up very nicely. So this just goes onto the chassis in this location, and about 6 screws hold it down to the main chassis. So I'll get those refitted, and then we can move on to refitting the card racks. That's the power supply box refitted, and the next thing I can fit are the 2 card racks. So one at each side, just a few screws hold these down. So one goes there, one on that side. I'll get the screws fitted, and then we can move on to the rear panel. I've refitted the 2 card racks. I've also refitted the left hand top ROM drawer guard, so that's in place, and the next thing I want to fit is the rear panel. So I have tested the fans on this, I've run them up and they seem to work fine. They're actually in quite good condition, the bearings don't seem noisy at all, so that was quite a surprise. So I'll get this bolted back in and I'll reconnect the wires. They connect to this terminal block here, and I'll bolt the on-off switch back in place. That goes into this position on the right hand side of the chassis. So I'll get this rebolted, and we're ready then to refit the power supply. I've refitted the rear panel, I've refitted the main switch, reconnected the ground leads, reconnected the wires from the back panel through to there's this tag strip here. It's just an interconnect between the rear panel and the connector that goes to the power supply. So I've got this switched to 240 volts, so if we've got this right, we should have mains on the 2 pins of this connector that's nearest to us, and the other 2 should just be shorted together. If it was on 120, you'd have 120 on each of the 2 connections, or each of the 2 pairs of connections. I'll get this powered up. Assume we've got this right, there shouldn't be any dramas with this. Drawing a bit of current, so we might have a bit of leakage in the filter on the back of the unit, but we'll see how that goes. There's a sealed filter and they do contain reefer style capacitors, and they do have a habit of going the same way as reefer caps, so I'll have to keep an eye on that. It's not a horrendous draw at the moment, but if it does start to rise when it's not running, then I will have to open that up and take the caps out and swap them. But we'll see how this goes. As I say, I have run the fans up outside of the unit and they did seem fairly quiet, so we'll hopefully now have nice quiet fans when we switch this on. So we'll power this up. And they are indeed nice and quiet. Both running. And the next thing I want to do is make sure we've got the wiring correct. I have of course had all these wires off, so I need to make sure this is right. And as I said, if we've got this wired right, just have to get away the meter for a second. If this is right, we should have mains across here. So, and we do. So that's because I've got the mains turned down a bit at the moment, just to be on the safe side. So it's set to 180 volts, and as we can see, we've got 180 volts across these connections. There should be nothing on the other two, so we'll just check that. And indeed we have what we should, which is nothing. So that's looking good. I'm going to leave this running now for an hour or two just to make sure that the filter's okay, the fans are fine, and then the next step will be to plug the power supply back into this. I still need to refit the reefer caps to the power supply and put the front cover on, or top cover back onto it, and then we can drop that into the chassis, test the rails, and we can test those at the various connections, the various edge connectors, and make sure all the rails are still behaving themselves. Again, I will leave that running once I've done that for a while, and from that point on we can hopefully start to reinstall the CPU cards. It's the next day and the power supply has survived its extended test. All the rails are now behaving themselves, the reset works the way it's supposed to, all the shutdown circuits seem to work the way they're supposed to, so I can now reassemble this. So the first step is to refit the top cover. So that's just this top plate, screws onto the underside of the motherboard. This is obviously now the right way up, and just 4 screws hold this in place. So I'll get this screwed into place. Notice the test points, these are just guides, it's just so you can push a probe through and it will contact the correct point on the PCB. So I'll get this bolted in, and we can then refit the power supply to the chassis. That's the top cover refitted, and we can now put the power supply back into the chassis. So this just drops in, and the 2 edge connectors at the bottom engage with the edge connectors on the chassis motherboard. So I'll get this put back in, and we can then start testing the power supply while it's in the machine. So it will be connected to the incoming main supply on the machine. We can recheck the rails at the supply, and then we can also start buzzing out the motherboard to make sure that the various supplies are getting to where they're supposed to. I've refitted the supply into the chassis, made sure it's engaged properly with the edge connectors, and we should now be able to power this up, and we should get the correct operation of the supply. So I've got the main switch in the on position for the machine, so if I just power up the bench supply, the fans should start up and we should be able to test the rails. So that sounds quite promising, and of course now the fans are running and the supply is refitted to the machine, it is properly drawing air through the supply. One other thing we can notice is that the supply current is about 220 milliamps, about 1/4 of an amp, which is pretty much exactly what it should be for this particular setup without any load on the supply. So it's looking quite promising from that respect. We'll get the multimeter in and we'll see if the rails are still within spec. So we should now be able to access these through this top cover. So logic ground, I'm trying to cover the meter up. So that's the 5 volt rail, and hope you can see that's fine. So that's the plus 18 volt rail, again that's fine. Minus 18. That's our plus 7. It's a bit high, but there's no load on it. And then we have minus 12. And then over on the second supply, we've got that's our 13 volt supply, which is fine. we should then have -17, which again is as it should be, and +17. So they're all fine, so they're all working the way they're supposed to. Turn that off. So what I will do next is buzz out the edge connectors on the motherboard, because although the supplies test fine here, if this isn't properly engaged with the motherboard, the supplies might not be making it onto the edge connectors. So I'll test the edge connectors, make sure the supplies are making it through to where they're supposed to, and from that point on we can start refitting the electronics. So the only thing that's given me any cause for concern now is there is a filter block that the mains lead plugs into, and it's sealed, but it does contain reefer style capacitors, so we all know what happens to those, and because it's sealed, have this go off and do any damage to the rest of the machine. So that's probably what I will do next, and then once that's been done and tested, we can start looking at the actual computer boards and start reinstalling those. So this is the filter block I'm talking about. Now unfortunately it does incorporate the mains connector, so I can't just completely remove it. You could replace it with a standard type, take this outer panel off, drill some holes and bolt a new one in. But what you can sometimes do is unsolder the panel off the back, and as I said, it does have reefer caps in it, and not only that, but this is actually getting quite warm. It's been on for maybe 3 or 4 minutes and it's getting distinctly warm around this area, so I've got a feeling that failure of the caps that are in there is fairly imminent. And as I said, reefer caps will fail at some point, so I need to get this out, get it apart, and see if we can replace the filter caps. If we can't, we'll have to come up with some alternative, maybe just remove them and put an external filter in, but either way we can't leave this as it is. It's a time bomb waiting to go off, so I'll see what I can do to try and get this opened up. I've removed the filter block and mains connector, and I now need to try and get the back cover off. As you can see, it's soldered in, and this is quite thick material, so getting this out is quite difficult. So I'm going to go over to the workshop, use the induction heater and see if I can get this rear cover off without doing too much damage. The worst comes to the worst, what we can do is just cut the back off this and put in a new connector. This is plastic, so it will melt if we get it too hot. And we can put one in that has an incorporated filter, but it would be nice to keep. There's quite a big choke in here, it would be nice to keep that, but I'll go and see if I can get the back off without doing too much damage. Okay, it's a couple of minutes later and I've got the cover off. Now I did not do this taking it apart. It is evident this capacitor has already failed, and you can tell that looking at the residue on the inside of the cover. And to get this off, all I did was gently heat it. Got an induction heater, gently heat it, and I think they used fairly low melting point solder. It just popped apart very easily, but you can see the kind of splatter residue on the inside, and as I say, this capacitor has failed. Exactly the same type that we have looked at previously, and it's failed in the same way. You can also see the white residue here from when it failed. The rest looks okay, so I'm going to cut this plastic away. It's obviously been destroyed where it was touching the capacitor, and we'll replace this capacitor and check the rest of it, make sure it's okay. The rest should be okay. They're just a few filters, and it's this device that causes the problem. So we'll get this replaced. Check there are no others in there. That I think there may be some further down, I can't really see, but we'll cut the plastic away. May have to try and get the PCB out, and because this is the X capacitor and there's normally a couple of Y's in there somewhere as well, so we'll see if we can find them, get these out of the way, and hopefully we can reuse this. I've unsoldered the board from the connector. It's normally soldered directly to the mains connector at these points. These solder into these holes. So I've desoldered that, carefully worked the board out, It's normally wrapped in a plastic sheet. I'll need to replace this. I've unsoldered the main X capacitor that normally sits directly across the main, so you can see this one's failed. Its internals are splattered on the underside of the top cover, and you can see why we need to get this out. There are two more large reefer capacitors, both of which have failed. You can see this one's split open and deposited its innards inside the case. This one has also split but doesn't appear to have failed yet, but it's looking like it's about to. And then we have two smaller ones on the top that also are split and bulging and will need to be replaced. So we've got 5 that need replacing, 3 very large ones, 2 of which have definitely failed, and the 2 small ones. So I'll get these replaced, clean up the board, get all the residue and the gunge that's come out of the capacitors out, but we should be able to reuse this. I'll buzz through the filters and make sure they're okay, but they're easy to repair. If we need to, we could even rewind them, but there doesn't appear to be any damage. It is just purely the capacitors, but you can see why we need to open this up and either replace it or repair it. So I'll get these swapped out. I removed all the old capacitors, and they're either all failed or just about to. 2 had definitely failed, and the internals from them was splattered on the inside of the unit, so I got those taken out the 2 small Y capacitors as well, and I've fitted replacements. So we've got the 2 Y capacitors, the big X, and the other 2 slightly smaller X capacitors. Unfortunately, you do need to remove one of the inductors to get to the Y capacitors, but it's not particularly difficult. Once I've done that, I completely cleaned the entire board. It did have a lot of residue from the failed capacitors splattered everywhere. Cleaned all that up, tested them, buzzed all the filters through, and they seem fine. If you do this, you do need to make sure you put back these insulation sheets. They stop the inductor shorting to the solder joints on the board. So what I can now do is cut out a fresh piece of insulation plastic, get that fitted, put the board back down into the housing, solder it back onto the mains terminal. Once I've done that, I will test it before I refit the rear panel, and assuming it's all it tests fine, this is ready to go back into the machine. So let's get it reassembled and tested, and hopefully we have managed to resurrect this. I've tested it and then resoldered the back panel on, so this is now ready to go back into the machine. The internals are now a slightly higher spec than they were. It was rated at 250 volts AC. I used X2 caps. This is now rated at 275, so slightly higher. Probably would have been okay with 250s, but as I was going to all the time and trouble to open it up, I thought I might as well improve the spec a little bit. So I'll put this back in the machine, get it all reconnected, and that should give it a new lease of life. But it certainly saves us having to try to either find a replacement for this, which would be very difficult, or come up with some alternative. And it's always nice to keep things as original as possible.